In this question we have to find out an eigenfunction of a linear time, a general linear time invariant system. So first let us define the eigenfunction to a linear time invariant system. Here we have LTI system and we have to find out the eigenfunction of the class of all continuous time linear and time invariant system. So to an LTI system, an input xt, this xt will be called an eigenfunction to this system if for this input the output is some constant a into xt, where a may be a complex constant. For any input xt, if for this input, if this function is input to an LTI system and if output is a constant into multiplication of the same input, this input will be called an eigenfunction to this system. So for an LTI system, we have already studied in system response. In that lecture we have studied that if you will give e to power j omega naught t in this system, and let's say for this LTI system its transfer function is hs, the Laplace of impulse response is given as hs. If you will give e to power j omega naught t to this system, the output will be e to power j omega naught t into the value of this transfer function at frequency omega naught. This will be j omega naught. This I have already proved in the lecture of system response. Okay, actually the output will be, the output yt will be e to power j omega naught t convolution ht, impulse response. And when we will write down the formula for convolution, we will get this type of output, where hj omega naught will be this is a complex constant. This is a complex constant. It will have some magnitude of hj omega, and it will have some angle also. So for e to power j omega naught t, output will be some constant into same input. So e to power j omega naught t will be an eigenfunction of an LTI system. Since we have been asked about an LTI system, so for an LTI system we can use, in LTI system, to find out the output we can use the formula of convolution. The output will be input convolution impulse response. If the system is not LTI, we cannot use a formula of convolution. Okay. And we have also studied that to the same LTI system, if you will give cos omega naught t, the output will be some constant. The output will be a cos omega naught t plus phi, okay, where a is mod of hj, the modulus of hj omega at omega equal to omega naught, and phi will be the angle of hj omega at omega naught. So this is the output, but this output is not, in general this output is not, it cannot be represented as some constant into cos omega naught t. It has some phase difference. Similarly, the same type of argument can be made if the input is sin omega naught t. This is hs. So in the same way, for input sin omega naught t, output will be a sin omega naught t plus phi. So this is not correct option, this is also not correct. For first option, if you will give input e to power j omega naught t ut, the output will be yt equal to e to power j omega naught t convolution e to power j omega naught t ut convolution st. In this case, you will not get e to power j omega naught t. This is input into a constant, into a complex constant. In this case, you will not get this answer. This I have already, in that lecture, in the theory lecture of system response, I have already taken this example, and I have proved that if you will multiply ut, that is a unit step, with the input e to power j omega naught t, the output will not be a complex constant into the same input. But if you remove ut, in this case the output will be complex constant into input. So this will only be the eigenfunction of an LTI system, a general LTI system. But if you will multiply ut, this will not be an eigenfunction. For the proof, you can refer that lecture, the theory lecture of system response. Here we are given with a continuous time function xt, which is periodic with t, and this function is sampled with a sampling. This function is sampled with sampling period of ts, and in the option we have relation between the time period of xt and the sampling period, and we have to find out of these four options in which of the cases the sampled signal will be periodic. So if let's say we have a periodic signal xt, let us take sinusoidal signal. This is a periodic signal xt, and it is sampled with sampling period of ts. So it means the samples will be, let us start with 0. x0 will be the first sample, next sample will be xts, then x2ts, x3ts. At t equal to, at the place of t, we will keep putting t equal to 0, t equal to ts, and the integral value of ts. This will be first sample, this will be, let's say this is x0, this will be x1, second sample, x2, x3, similarly x4ts, 6ts, x7ts, and so on. This will be called x7, this will be x6. So these will be the samples. Now we have to find out relation between t and ts such that these samples will be periodic. Here we have the time period. This is time period. So if you want these samples to be periodic, let's say this sample is periodic with, here we have value of n, this is xn, let's say it is periodic with n equal to 4. So what you will write, x0 is equal to x3, 1, 2, 3. If it is periodic with 4, x0 has to be equal to x4. The value of x0 must be equal to x4, x1 must be equal to x5, and so on. Okay. So for some value of n, the sample sequence has to be repeated. So let's say it is periodic with, the sample signals are periodic with n equal to n. After n samples, it will repeat itself. So we will write x0 this must be equal to x and ts. Like if it is periodic with 4, x0 is equal to x0 is equal to x4. It means x0 is equal to x into 4 means x4 is x4 ts. The discrete signal x4 is equal to x4 ts. So if it is periodic with 4, x0 is equal to x4 ts. Similarly, if it is periodic with n, x0 will be equal to x and ts. These are samples of continuous time signal, and it is given that this continuous signal is periodic with capital T. So we will say x0 will be equal to x capital T. This will be equal to x 2t, because it will repeat after t, and this will be equal to x kt for any integer k. This is an integer, and n is also integer, because if it is a discrete time system, the variable n is always an integer, so capital N will also be an integer. So this is given because the continuous time signal is, the continuous time function is periodic with t. So this is given. Here x0 has to be, to make the sample signal periodic, x0 has to be equal to x and ts for some integer n. So this is equation 1 and equation 2. So from equation 1 and 2, x0 has to be equal to, or x, here you have x0, here also you have x0. So x and ts has to be equal to x into kt. Here x0 is equal to x and ts, here x0 is equal to xt, x2t. It is not necessary that sample signal will be periodic with same period as the continuous time signal is periodic. So in general we will say x and ts has to be equal to xkt. So from this equation we can write n ts has to be equal to k into t for any integer n and k. Now coming to option, if we check the first option, t is equal to root 2 ts. So if you will put t equal to root 2 ts, we have n into ts will be equal to k into root 2 into ts. ts and ts will be cancelled. n is equal to k into root 2. n is an integer, k is also an integer, and root 2 is an irrational number. So if you will, it doesn't matter what is this integer k is. If you will multiply this integer with an irrational number, you are not going to get, you are never going to get any integer. If you have an integer, it doesn't matter what is the value of this integer. If you will multiply this integer with an irrational number, you are never going to get an integer, because an irrational number cannot be written in the form of p by q. So the first option does not satisfy this equation. Coming to second option, in the second option, n ts is equal to k into value of t is 1.2 ts. So n has to be equal to k into, for any integer n, it has to be equal to any integer k into 1.2. So if you will multiply, if you will put the value of k equal to 5 into 1.2, this will give you 6. So n is equal to 6 here. So this option satisfies our condition. This is the correct option. This will not be, because this will not always be periodic, because if t and ts has irrational relation, we are not going to get the sampled signal as periodic signal. So always is not a correct option, because if this option is not valid, so always is not a correct option. And since this option is satisfying our condition, so never is also a wrong option. So in this case, after 6 samples will be periodic with n equal to 6. You can verify it also. If t is equal to 1.2 ts, you have samples x0, xts, x2ts, x3ts. So x0, okay, this is x0. xts will be nothing. This is nothing but t divided by ts is equal to, this is the another method, the shortcut method, or this can be easily understandable. ts is equal to t divided by 1.2. So ts is equal to, here you will get the continuous time, the sample will be the value of continuous time signal at t equal to capital T divided by 1.2. x2t will be 2t divided by 1.2. This will be x3 into, and value of ts is t by 2. So you will get 3t divided by 1.2. This is 4t divided by 1.2. This is 5t divided by 1.2. This is 6t divided by 1.60, not 60, 60. 6 into capital T divided by 1.2. Here we will have the 7th sample will be 7t divided by 1.2 and so on. x0 will be equal to, this is equal to x, any integral value of t. So here you are not going to get integral value of t, so x0 will not be equal to this. Here also you are not going to get integral value of, integral multiple of capital T. Here you will get integral multiple of capital T for the first time, because this will give you 5. So here you are going to get x5t, and x0 is equal to x5t. So x0, this is repeated at this instant. This is at 6th sample. This is nothing but 6. T divided by 1.2 is ts. So this is 6th sample. And for periodic, only this is not necessary that if one value is repeated, if only one value is repeated, we cannot say the signal is periodic. The whole characteristic has to be repeated. So this next, the second sample has to be big. The second sample has to be equal to the 7th sample. So x7t divided by 1.2, this can be written as x60 divided by 1.2 plus t divided by 1.2, and this will give you 5t plus t divided by 1.2, and if it is periodic with t, so x5t plus t divided by 1.2 will be x t divided by 1.2. So this is equal to the second sample. Similarly, if you will check the 8th sample, you first take 60 divided by 1.2 out of this, you will get this is equal to x 3t divided by 1.2, the 4th sample. Here you will get x 2t divided by 1.2, that is equal to the third sample. But if instead of 1.2, if you will check for first option, if instead of 1.2, if you will put root 2, here, you are never going to get an integral multiple of capital T. If you are never going to get an integral multiple, x0 will never be repeated. So I hope this much explanation is enough for this question. So I will move to the next question. Here we are given with the relation xn and xn minus 1 in terms of n, and the initial conditions are given as x0 is equal to 1, x1 equal to 1. and xn equal to 0 for n less than 0, then we are required to find out the value of x12. So if you will put n equal to 12 in this equation, we will get the value of x12. And here you will get x11. This will be equal to 1110 to power 12 into L. Okay, so basically in this question we have to find out a 2 by 2 matrix is given and we have to find out this matrix to power 12, and after getting this matrix we will multiply this matrix to 1, 10, and the first row of the multiplied matrix will give you the value of x12. So we have to find out this matrix to power 12. So to find out this matrix, we will use Clay-Hamilton theorem. The Clay-Hamilton theorem says that this matrix A satisfies its own characteristic equation. So we will first find out the characteristic equation. The characteristic equation is given by lambda I minus A modulus equal to 0. So lambda I minus A will be lambda into 1001 minus A is 1110. This will be lambda minus 1 minus 1 0 and lambda, and we have to equate it to 0. So this will give you lambda minus 1 into lambda equal to 0. Lambda square minus lambda is equal to 0. So this is the characteristic equation of this matrix, and Clay-Hamilton theorem says that this matrix A satisfies its characteristic equation. It means if at the place of lambda, by solving this equation, lambda will give you the two eigenvalue of this matrix. And the Clay-Hamilton theorem says this matrix A satisfies its own characteristic equation. It means A square minus A will be equal to 0. Here we will have minus 1. So the characteristic equation will be lambda minus 1 into lambda this into this minus 1 equal to 0. So here we have lambda square is equal to lambda plus 1. This is characteristic equation, and Clay-Hamilton theorem says A square will be equal to A plus, at the place of 1 we will have the identity matrix I. So we have the value of A square in terms of A and identity matrix, and we have to find out A to power 12. So A square is A plus I. What will be the value of A4? This is A square into A square. It means A plus I whole square. This will be A square plus 2A plus I square, and the value of A square is A plus I plus 2A, and I square is nothing but I. So here we will get 3A plus 2I. The value of A4 in terms of A and identity matrix. Again we will try to find out if A4 is given. A square is A plus I. Now we will find out A to power 8. A to power 8 is A4 into A4. So this will be 3A plus 2I whole square. 3A plus 2I whole square. This will be 9A square plus 12A plus 4I square, and I square is equal to I. Again A square is A plus I plus 12A plus 4I. Here 9A plus 12A, 21A 9i plus 4i, 13i. This is a8. Now we have to find out a to power 12. This will be a8 into a to power 4. 21a plus 13i, and a to power 4 is 3a plus 2i. So this will equal 63a plus 63a square plus 42i plus 39i, sorry, 21a into 2i, 42a plus 39a plus 26i square is I. 63a square is a plus I. Then we have a plus I. This is 81a plus 26i. 63a plus 81a. This will be 124a. 124a plus 63i plus 26i. This will be 89i. So a to power 12 is 124a plus 89i, and this can be found out very easily. Instead of multiplying this matrix 12 times, which is not possible in gate exam. In an examination, it is not possible. This will not be time efficient, so we will find a to power 12 by this method. So then we have 124a means 124, 124, 124 and 0 plus 89i means 89, 0, 0 to 30, 124, 124 and then we have 89. This is a to power 12, and x12 will be the first row of a to power 12 into 10. Here there is a calculation mistake. 63 plus 81 will be, this will be 144 instead of 124. Here we have 144. Okay. So here we have 144, and 144 plus 89 will be, okay, so x12 will be 233, 124 into 10. So its value of x12 will be 233. This will be the answer. In this question we have to find out this integral, and the path or the contour of this integral, this closed path, encloses the point 2 pi j and minus 2 pi j. The closed path encloses, let's say this is 2 pi j and this is minus 2 pi j. So the general formula to calculate this integral is only this much of the integral will be, this is equal to 2 pi j into residue of this function, residue of the function at points or at poles enclosed by the contour C. Okay, so in this function we have triple pole at 2 pi j. Okay, and the formula to calculate residue is residue at 2 pi j will be, this will be equal to, this is, let's say this is fz, it has triple pole, so we will multiply z minus 2 pi j to power 3, and it will be differentiated twice with respect to z, d2 by dz square of this, and then we will apply limit z tends to 2 pi j. This is the formula This is the formula to calculate residue at any pole P. If any pole P has, if the pole P has an order of n, so the formula, the general formula to calculate residue is equal to limit z tends to P dn minus 1 divided by dzn minus 1, and here we have 1 upon n minus 1 factorial also, 1 upon n minus 1 factorial, 1 upon n minus 1 factorial dn minus 1. The order of differentiation will be n minus 1 into fz into z minus p to power n. So when you will multiply z minus p to power n, the denominator which will have z minus p to power n, this will be cancelled. So to fz we have to differentiate n minus 1 times, where n is order of the pole. Order of the pole. So here we have order of the pole, n is equal to 3. So when you will put n equal to 3, we will have to differentiate this function twice. So here we will have residue at 2 pi j. Since 2 pi j is enclosed by the contour, we will find out the residue at 2 pi j. And to find out this integration, we will apply this formula. So residue at 2 pi j, 1 upon n is equal to 3. So 3 minus 1 factorial, 2 factorial, and 2 factorial is 2. d2 by dz square of fz into z minus pole cube will be, this will be cancelled, and here we have sin z, and limit z tends to 2 pi j. So this will give you minus 1 by 2. The cross differentiation of sin z will be minus sin z, and limit z tends to 2 pi j. So this will give you sin z divided by 2, and limit of z tends to 2 pi j. So this is 1 by 2 sin 2 pi j. Now to calculate sin 2 pi j, we'll use sin theta is equal to e to power j theta minus e to power minus j theta. E to power j theta is 2 pi j minus e to power minus j theta divided by 2j. So we are calculating residue at 2 pi j. This is residue at 2 pi j. So 1 upon 4j, and j into j is minus 1, so e to power minus 2 pi minus e to power plus 2 pi. 1 upon 4j, e to power 2 pi is 533.78. So e to power minus 2 pi will be 1 by this, so I am taking it as negligible, 0 minus this. So we have minus 53378 divided by 4j. The value of residue at 2 pi j is this. Now formula for this integration is 2 pi j into the sum of, earlier I forgot to write sum of residue poles enclosed by the contour C. Here we have only one pole, although it has degree of 3. and residue is given by that equation. So this will be 2 pi j into minus 533.78 divided by 4j, and here we have minus 1 by 2 pi. So this 2 pi will be cancelled, j will be cancelled, minus and minus will be cancelled. So we have 533.78 divided by 4. When we differentiated it, we got the double differentiation of sin z was minus sin z. Okay, so I missed the minus sign here. Here we have to calculate minus sin z. Z tends to 2 pi j. So I missed one minus sign. Then we have plus sign, and then we have minus sign. The answer will be minus 133.4. Here we have a causal signal, and we have to find out the Laplace transform of this signal. Options are given as 1/1 plus e to power minus st by 2. The option is okay. So to find out the Laplace transform of this periodic signal, this is a periodic signal. It will start from 0 and it will go to infinity. So to find out Laplace of this signal, first we will find out Laplace of the first square wave. First, this wave only. This is 0 and this is t by 2. So this can be represented as ut minus t by 2. And Laplace of the signal will be 1/s minus e to power minus st by 2 divided by s. 1 minus e st by 2 divided by s, provided the region of convergence will be the real part of s will be greater than 0. If you have ut, the region of convergence sigma, this has to be greater than 0. And if you have u minus t will be anti-causal. So in that case, sigma has to be less than 0. So Laplace transform of this signal is 1 minus e to power minus st by 2 divided by s. Now, after finding out Laplace of this signal, let us find Laplace of this signal. This signal is nothing but this is delayed version of this signal, and the delay is this signal starts at 0, this signal starts at t, and these two signals are identical. So the delay is t. So if you will delay this signal by t, the Laplace transform of the delayed signal will be divided by s, and corresponding to delay we will multiply e to power minus s into delay, and delay is capital T. Similarly, Laplace of this signal will be, if you compare with first signal, this is 2t times delayed. This is delayed version of this first square wave, and the delay is 2t. So Laplace of this third signal will be this. Let's say this is fs. So fs into e to power minus 2st. So the Laplace of this whole signal will be addition of individual Laplace of each block. So for the first block, let's say this is fs, this is fs. The overall Laplace will be fs plus fs into e to power minus ts plus fs into e to power minus 2ts, and so on. taken common, 1 plus e to power minus ds. This is a repeated question. The same question was asked in 90s in GATE examination only. This question was asked in, I don't remember the exact year, but this question was asked in 90s. E to power minus ds, e to power minus 2ds up to infinity. So this is the geometric series, and the common ratio is e to power minus ds. So we can apply this formula. First term is divided by 1 minus r, provided mod of r is less than 1. So r is e to power minus ds. So mod of e to power minus ds must be less than 1. And what is mod of e to power minus ds? E to power minus t. This is sigma plus j omega. This has to be less than 1. So mod will give you e to power minus t into sigma. E to power j omega t. This will give you 1. The mod of this quantity is e to power minus t into sigma. This has to be less than 1. And since this signal is causal, while getting the Laplace of ut 1 upon s, the condition is sigma has to be greater than 0. So if sigma is greater than 0, this quantity will be less than 1. So our condition of r has been satisfied. We can use this formula. Fs into 1 divided by 1 minus r, and r is e to power minus ts. And Fs is 1 minus e to power minus ts by 2 divided by s into 1 minus e to power minus ts. E to power 1 minus e to power minus ts can be written as, this can be written as e to power ts by 2 whole square. So 1 minus a square is 1 plus a into 1 minus a. So this will give you, this much quantity will give you 1 minus e to power minus ts by 2 into 1 plus e to power minus ts by 2. So 1 minus e to power minus ts by 2 will be cancelled. So the answer will be 1 divided by s into 1 plus e to power minus ts divided by 2. So this is the answer, and no option is matching with the answer. So for this question, marks was given to all the students. In the answer key, you will find MTA, marks to all. In a purely RLC network, we have a network in which we have resistors, inductors and capacitors, this type of elements, and they all are connected either in series or in parallel and excited with a source of this kind of source. Okay. So let us first talk about this circuit. The circuit consists of resistor, linear resistors, inductors and capacitor. So if a circuit consists RLC component, that circuit will be a linear circuit. This will be a linear circuit. If circuit are free from any switches, no switches are involved, and circuit is RLC circuit, that circuit will behave as a linear circuit. We can apply superposition theorem to that circuit. Okay. And this circuit is connected to a source which has non-zero impedance. Okay. So we have to find out the form of output. We are given with 4 options. So in general, what will be the form of the output voltage across any resistance? The output measured across a resistor. The output is measured across a resistor. So we have to find out the general form of output. So this is the form of source. The amplitudes are not equal to 0 and omega naught is not equal to 0. It means the source is, if I open this series, the source will be A1 cos omega naught t plus A2 cos 2 omega naught t plus A3 cos 3 omega naught t. It means, let's say this is fundamental component. So in this source we can say that along with the fundamental components, two harmonics are present. One is second harmonic and the third is, this is the another harmonic is third harmonic. So this source can be, now we have to find out the output across a resistor where we have three inputs, the sum of three inputs in a circuit. The source has some impedance. This is the impedance of source, and we have resistances, inductances and capacitances. They are connected in, let's say they are connected in series, and this is source impedance. And this source has three voltages. It contains voltages of three different frequencies. And let's say we are interested in finding out the voltage across this resistor. So if this is a linear circuit, the voltage or current through any element will be directly proportional to the amplitude of source. And the second thing is, this is a linear circuit, so we can apply superposition theorem. In superposition theorem, what do we do? Instead of finding output due to this voltage, we will find output is due to source V1, then output due to source V2, then output due to source V3. And after finding out individual outputs, we will add all those three outputs. Then we will get output due to the voltage V. So this source can be represented as, or this circuit can be represented as, then we have V1 plus V2 plus V3. So instead of finding out response due to V1 plus V2 plus V3, let us first find or try to find out the form of output individually due to V1, V2 and V3. And we have V1, it has some source impedance Zs, and here you have the resistance across which we are interested to find out the output. And let's say here we have the rest circuit. This is rest circuit. So this is due to V1. Similarly, we will have some output due to V2. This is V2. Then we will have V01. Then we will have V02. This is source impedance. This will be V0. So in superposition, what we will do? We will find out outputs individually due to all the inputs, and later we will add all the three outputs. Okay. So this was superposition, and since the circuit is linear, so the property of linear circuit is the voltage across any element or the current through any element will be directly proportional to the amplitude of the voltage. So the amplitude of V1 is A1. So we can say that the output voltage across this resistor will be directly proportional to A1. And the form of the output V01 will be, this will be directly proportional to A1. So let's write K into A1. And due to RLC circuit, there will be some phase difference. This will be cos omega naught t plus phi 1. Similarly, output voltage due to V2 will be some another constant 5K. And certainly K1 will not be equal to 1. The amplitude of voltage across this resistance will not be equal to the amplitude of source voltage, because the source has some impedance. So when current will flow, there will be some voltage drop across the source impedance. Okay. And one more thing is very important. The frequency of the output, if this is an AC signal, so the output will also be an AC signal. The frequency of the output has to be equal to the frequency of input. So the frequency of input is omega naught. So the frequency of output will also be omega naught, but with a phase difference. So let's say the phase difference is 5. And K1 will not be equal to 1. So similarly, V03 will be K3 into A3 cos 3 omega naught t plus phi 3. So the total output V0 will be V01 plus V02 plus V03. So let's say this is V1, this is V2 and this is V3. So in compact form, output can be written as summation Vk, k is equal to 1 to t cos k omega naught t plus phi k. Okay. The phase contributed at different frequency will be different, because if you have an RLC circuit, the impedance contributed by resistance is R. This is independent of source frequency. Let's say source frequency is omega naught. The impedance or the reactance contributed by inductor is omega naught L, and its impedance is 1 upon omega naught C. I am taking only magnitude. Now if you will change the frequency of source, if you will change the frequency of source to 2 omega naught, the impedance provided by resistance will be same as R, but this impedance will be 2 omega naught into L, and this impedance will be 1 by 2 omega naught C. Their impedance will decrease, their impedance will increase. So the circuit will become more inductive. So the overall phase contributed by this RLC element phi will be, this will change. This will be different at different frequencies. That's why I have taken phi 1, phi 2 and phi 3. Not I have taken these phi 1, phi 2 and phi 3 as different. Okay. And Vk is not equal to Ak. The amplitude of output cannot be equal to the amplitude of input due to some voltage drop across the source impedance. So Vk will not be equal to Ak. Okay. So this is the form of output. So A option will be correct. So this was the whole analysis to find out the form of output. If you will check through option, D option is absolutely wrong, because there is no, here you have k equal to 1 to 4. So if k is equal to 4, in output you have a frequency component of 4 omega naught, while in input there is no frequency component of frequency 4 omega naught. And as long as the circuit is linear, okay, the frequency of output cannot be different from the frequency of input. If input has 3 frequency component, so the output will have the corresponding 3 frequency component only. If the circuit is non-linear, then the output may have some harmonics, but here we have the case of linear circuit. Okay. So this is wrong. In D option, there is no output corresponding to 3 omega naught frequency. But superposition says this is third input. So for third input also there will be some output. So this option is wrong. And in option C, the amplitude of voltage across the resistance is same as the amplitude of input. but there has to be some voltage drop across source impedance. So this option is also no. So this way, by checking options, you can easily solve this question, and this will be the general analysis. This is the general method to find out the form of output. This question, these are the inputs to a first order low pass filter with time constant t. So the general transfer function of a first order low pass filter will be, since this is first order, we will have s into t, where capital T will be the time constant. This is first order low pass filter, and we have three inputs: impulse, unit step, and ramp, and we have to match the outputs. Okay, so one method is we keep an impulse here and we find out the output, or what we can do, let us find out the output in Laplace domain and take Laplace of all these outputs in the option, and then match the Laplace of output due to input and Laplace of these options. So Laplace of output for impulse will be, Laplace of this is 1, this is 1 by, so Laplace of output when input is lambda t, this will be 1 by 1 plus st only. Laplace of output for unit step, this will be 1 by s into 1 plus st, and Laplace of output for ramp will be 1 upon s square into 1 plus st. Okay, now take the Laplace of these options. Since this is given that the output is for t greater than 0 only, so you can multiply here ut, because we cannot take Laplace of 1. We have to have ut or u minus t. Okay, here also we will have ut, and here also we will have ut. So we will take Laplace, then we have 1 by s minus 1 by s plus 1 by t. The general form of first order filter will be not 1 by 1 plus st, there will be some gain k divided by 1 plus st, and also we will have k. Laplace of this will be 1 upon s plus 1 by t. So this will give you t divided by 1 plus st, and here we will have 1 by t divided by s into s plus 1 by t, and this will be equal to, if you multiply with t, 1 divided by s into 1 plus st. So now if you try to match t divided by 1 plus st, this is matched to this form, k divided by 1 plus st, where k will be equal to t. Okay. So impulse is matched to r, and this is matched to 1 upon s, k divided by 1 plus st, where k will be equal to, here k is equal to 1. So p is matched to, this is output for unit step, so p is matched to unit step, and the rest ramp will be matched to q. When you will take Laplace of this equation, you will get tut 1 upon s square. In the option we have 1 upon s square minus t into, then we will have 1 upon 1 plus Laplace of e to power minus t divided by capital T will be first we will have Laplace of t will be so t into 1 upon s minus the Laplace of this quantity will be 1 upon s plus 1 by t 1 upon s square minus t into 1 by t divided by s into s plus 1 by t will be 1 upon s square 1 upon s square minus t divided by s into 1 plus st. Now if we further solve it, we get s square into 1 plus st, and here we have 1 plus st minus st. This is cancelled and we get 1 divided by s square into 1 plus st. And if you put k equal to 1, this will be matched to the Laplace of output due to RAM. Okay. Xn is given and x e to power j omega is dtft of xn is discrete time Fourier transform of xn. Then we have to find out this integral. This type of question has been asked many times in GATE. So in this type of question, what we do, we will write formula for x e to power j omega. This is xn e to power minus j omega n summation n equal to zero to infinity, or n equal to minus infinity to plus infinity. And xn is 1 upon 2 pi integration over 2 pi, since dtft is periodic with 2 pi, so then we will have e to power j omega n d omega. So you have to find out integration in terms of x e to power j omega, so we will use this formula. And in the integration with x e to power j omega, sin square 2 omega is multiplied. So sin square 2 omega is, this is nothing but, and here in the multiplication with x e to power j omega, we have e to power j omega n. So we have to relate sin square 2 omega with e to power j omega n. So sin square 2 omega is, this is 1 minus cos 4 omega divided by 2. 1 minus cos theta is sin square theta by 2. So sin theta by 2 will give you 2 omega. So sin square 2 omega is 1 minus cos 4 omega by 2. This will be 1 upon 2 minus 1 upon 2 into. Now we have to relate cos omega with e to power j omega n, and value of n can be, this value of n can be put anything to the both side of this equation. So cos 4 omega can be written as e to power j 4 omega plus e to power minus j 4 omega divided by 2. Here we will have 1 by 2 minus 1 by 4 into e to power 2 j j4 omega plus e to power minus j4 omega. Okay, so we have to get e to power j4 omega, so we will put n equal to 4. So in that equation we have to basically we have to find out x e to power j omega into this quantity. So first we will put n equal to 4. x4 will give you, and from this equation we can find out the value of x4, x minus 4 or x0. x4 will be 1 upon 2 pi integration. This is integration over 2 pi, so you can take limit as from minus pi to plus pi x e to power j omega e to power j4 omega d omega. This is value of x4. x minus 4 will be 1 upon 2 pi minus pi to pi x e to power j omega into e to power j minus 4 omega d omega. And x0 will be 1 upon 2 pi minus pi to pi x e to power j omega, and if n is 0 this will be 1. This. Okay, we have to get sin square to omega. So sin square to omega is nothing but 1 by 2 minus this. So multiply in this equation, multiply both sides with 1 by 2, and in this equation multiply both sides with 1 by 4, and in this equation also multiply with 1 by 4. So first add these two equations. What we will get? x4 plus x minus 4. This will be equal to 1 by 2 pi minus pi to plus pi x e to power j omega and by addition this will give you cos 4 omega. When these two terms will get added, this will give you 2 cos 4 omega, and we will have 2 cos 4 omega let us not multiply with 1 by 4, just add these two terms. So here we get this 2 and this 2 will be cancelled. I will get 1 upon pi minus pi to pi x e to power j omega cos 4 omega d omega. And what will be the value of 2x0? Here we have the value of x0. So 2x0 will be, 2 will be cancelled. This will be equal to 1 upon pi minus pi to pi x e to power j omega d omega. Then you have multiplied with 1. So what will be the value of 2x0 minus x4 minus x of minus 4? This will be equal to, then simply subtracting this from this. We have 1 upon pi from minus pi to plus pi x e to power j omega into 1 minus cos 4 omega. Okay. In the left hand side Let it be as it is. First solve this. 1 upon pi minus pi 2 plus pi x e to power j omega. This will give you 2 sine square 2 omega d omega. So if you will take 2 to the left hand side, we have to multiply it with 1 by 2. And this is the required integration. We have to find out the value of this integration only. So this is nothing but 1 by 2 into 2x0 minus x4 minus x of minus 4. So x4 is, if you will put 4 at the place of n, you will get x4 as, if you will put n equal to 4, in neither of the terms you will get del 0. Okay, so you will get x4 is 0, x minus 4 is also 0. So this is 0, this is 0, 2 and 2 will be cancelled. So value of this will be x0, which is, and you will put x0 n equal to 0. This term will give you non-zero value. Okay, and this value will be 8. So the value of this integration is equal to 8.